guys.
Yes, sir.
Yes,
Huh,
sir.
okay. So, if you compare with the normal shell, spherical shell, in this spherical shell, inside this spherical cell, electric field is zero. This is really important. I will mention this inside. Inside this sphere, electric field will be zero. Inside the spherical shell, electric field is zero. But if you take solid sphere, on the surface it will remain same. Outside the surface, it will be same, like E is inversely proportional to the R square. But in case of solid sphere, you have charged particle even inside the sphere. So here, charge is not zero. If charge is not zero, then electric field cannot be zero. Q inside is not zero. And if Q inside is not zero, electric field inside cannot be zero. Because electric field is always because of the charge. Electric field is always because of the charge. So inside, if you see, example, if I take this sphere and this sphere, in this sphere you have, let's take three charge particles. In big sphere you have inner three and outside seven charge particles. Now tell me guys, where you should have more electric field? Anvita, where you should have more electric field? In one or two?
Two.
Two, because more charge, more electric field. Reason, because we know electric field directly depend upon the charge. That's the reason. If you see ki here electric field depend upon the R up to the surface. Why? Because in this case, if you increase R, see here, here it is, let's take R1, and here it is R2. You know R2 is greater than R1. It means charge present in R2 will be greater than charge present in R1. Okay, and in this situation, what will happen? More radius, more charge, more electric field. Understood? That's why in this case, electric field directly depend upon the R, because more R means more charge. But after surface, if you increase the R, charge remains same. Charge is not increasing. That is the biggest difference in case of solid sphere. Because on surface, it will remain same. Any doubt, guys? Understood everything?
Yes, sir.
So distribution of charge. If even after even after the distribution, charge will be same, and I already explained this point in the chapter of Coulomb's law. While I was doing Coulomb's law, what happened? We discussed कि if you take total charge, just give me a minute, I will पूरा अंधेरा जाता है. Give me a minute, not more than 30 seconds. हाँ सर। 3-3 फुट के 5 था। 3 तो थोड़े से ऊपर हो तो ठीक रहेगा, थोड़ा बहुत कट जाए। ठीक है, मैं तेरा नंबर भेजो। ठीक। So guys, what I was trying to convey even in the Coulomb's law, कि if you take initial charge Q1 and another charge Q2, total charge is Q1 plus Q2. Even after distribution, charge total amount will remain some. Q1 dash will be equal to Q2 dash. Do you remember we did the same thing in Coulomb's law? Yes or no?
Yes, sir.
So that's why I will not take much time, but this is an important concept where you understand total charge will remain same. Charge before distribution, charge after distribution, it will be redistribution up, it will be same. Okay, that's why total charge will remain same. Once you connect, potential will be same. So if you have V1 potential, this is V2 potential. So and you talk about the potential, then potential V1 will become equal to V2 after connection. Right? So if you want to calculate new charge after redistribution, it will depend upon the radius. Less radius, less charge. More radius, more charge. As simple as that. Less radius, less charge. More radius, more charge. Okay. That's why new charge ratio will depend upon the radius, and we did this already. Okay. Next charge in case of pendulum, we did this also. If you take any mass, this have mass m and charge q. Okay. So this have mass m and charge q. So what will happen in this case? T cos theta above part will be equal to the lower part, mg. T cos theta above part will be equal to the lower part. Second, inward T sin theta outward F electrostatic force will be same. When you take ratio, divide equation 2 by 1, correct? Equation 2 from 1. What will happen? You will get tan theta. We already did this. You have to understand this most of time. Here sin theta value will be perpendicular by hypotenuse. Perpendicular is r distance, and hypotenuse will be 12. Correct? Is this correct? R by 12, because r value is 2 and l value is 12. Any doubt, Chandana? In sin theta, perpendicular will be r and hypotenuse will be 12, right? Chandana,
Yes, sir.
any doubt?
No, sir, no doubt.
This is wrong. Actually, if our whole distance between the two masses is r, then distance from the center to this ball will be r. This length is l. Now you calculate, sorry, this will be r by 2 because total is r, half is r by 2. So if you calculate sine theta here, what is your perpendicular value? R by 2. What is hypotenuse value? L.
Yes, sir.
That's why it is like this. Okay. And because length is very long and theta is very, very, very small, that's why you will say sine theta is almost equal to theta. or equal to tan theta, because here we consider our tan theta is approximately equal to sin theta. Tan theta approximately equal to sin theta, and sin theta value this, which is theta y. Angle is extremely small. Wire is very long, and because of this angle is negligible, your perpendicular distance will be almost equal to L approx. If you take this long length and you take this long length, correct? Angle is very small in this case. This is y, this is L. Can we say both are approximately same? Any doubt, guys?
No,
So
sir.
F by F, mg will be equal to tan theta, and tan theta is equal to theta, and sin theta. Sin theta value is this. Correct? That's why this is given. By this, you can see if L value is approximately equal to y, then if you take this equation, can you say your k q square will be equal to r cube mg by 12? Correct? I took only the second part. This- So can I say q square is directly proportional to r cube, or L will be directly proportional to r cube? Make sense? Through R, you can calculate what is the impact of the force, whether it is attraction or repulsion. Any doubt?
Sir, could you explain the KQ square is equal to R cube by 2 LMG?
This KQ square remains same. Lower part, R square mg will go to another side. It will become R cube mg, this side with this R. Correct?
Yes, sir.
And 2L remains same. Got it?
Okay, okay.
Yeah. That's why Q square directly depend upon the R cube. Or if you consider this L, lower L, then L directly proportional to R cube. This thing will do in the electrostatic. If you apply any external electric field E, and you have any metal, within the metal, electric field will induce in the opposite direction, because whatever change you try to do in anything will resist the change. Anything will resist the change. Got it? Anything will resist the change. If you are applying external electric field E, then E induced will be there in the opposite direction. So E induced. Got it? And what is the net impact? Example, if you apply force on anybody, even on the let's take mobile, you apply 100 Newton force. This mobile, because of its mass, resists some change. Let's say 5 Newton resistance is there. What is the net impact of our force? Only 95. Same thing we wrote here. Understood?
Yes, sir.
Hmm. So induce we can calculate using same formula. And how to calculate E net? It depend upon the E, also dielectric constant. K is dielectric constant. It means medium. It will depend upon the medium. And K is the property of this material, whatever you kept here. If it is a strong medium, then impact will be less. Example, if I take phone, then it creates less resistance. But if I take table and I am applying same 100 Newton force, but table will resist like 70 Newton. So our net force remaining, in this case remaining is 95, here it is 30. What does it depend upon? It depends upon the nature of material. It depends upon the nature of material. Got it? It depends upon the nature of material. Understood, guys?
Yes, sir.
Yeah. So it look like it inversely depend upon K, but at the same time there is a negative charge also. In this way, you will see ki E induce, how much electric field will induce will directly depend upon the K value. Okay, it means how much will be the resistance created by the system depend upon the nature of material. If I am taking table, it will create more resistance. If I take ball, take less resistance. Create less resistance. Nature of material. If you have two electric field in different direction and have some angle theta, so E net will be E1 square plus E2 square plus 2 E1 E2 cos theta. Same like how when you take resultant, it is like A square plus B square plus 2AB cos theta. Understood? Same method. There is R angle difference theta. But remember, angle is taken in this situation between the two electric field, not the resultant. This is total angle. If in question this angle is given, then it will be wrong. You will take theta, but it is not theta. Theta is between two electric field. Okay, theta is between two electric field. If you take pendulum, what will be the impact? In case of pendulum, this is the formula. Time period is equal to 2 pi L upon G. L upon G. So, you know, in general, when you calculate time period, it is, basic formula is under root L upon G effective. This is the real formula. Time period is equal to L upon G effective. L upon G effective. Now, how to calculate G effective? You know G effective means G value minus whatever is the G value of the in a given medium. If you take here, how to calculate G? You know force is equal to MA and force also is equal to charge into E. So what will be your acceleration? Acceleration will be QE by M. QE by M. So that is acceleration value. So what will be your G effective in this situation? Your G effective will be G minus A. Your G value is G. इनका खड़े हैं हाँ बस शुरू करने में थोड़ा सा टाइम लगा QE by M. फिर अदर आजाद का फोन आया था करागा फिर ये थोड़ी होंगे पत्थर 3-3 फुट वाले चाहिए होंगे या थोड़े बड़े चाहिए हैं 3 लोगे मैं उसको रखूंगा any doubt guys that's why we are considering this of the electric understood this G minus A yes or no and this is pendulum
Yes, sir.
you should know real formula G effective. G effective is G minus A and A value is where when electric field is acting in the upward direction here. It is opposite to the MC. एक मिनट में और बेटा को बैठ जाओ एक guys give me 2 minutes on हाँ, so What is happening in first situation? Mg and like basically G, your this part and this part are acting opposite to each other. That's why you have minus sign here. Second, if electric field and force both are acting in the downward direction, in this case your G effective will be G plus A. Okay, that is the biggest difference. Here both are in the same direction, that's why G plus A. Here both are in opposite direction, that's why G minus A. Okay, if they are acting perpendicular to each other, in this situation, your net electric field, like net system force will act in this direction. So how will you calculate your G effective? G effective is G square plus A square under root. Here A value is QE by M. Understood? Why? Because both are perpendicular to each other. That's why we are using this square under root form. So we use square under root form only when they are perpendicular to each other. Okay. Next, you know force is equal to this. Force is also equal to M into A. M will go to another side, QE by M. And because you know this acceleration is also equal to dv by dt, correct? Or you can say velocity by time. So time will go to other side, and that's why this. Tell me, guys, any doubt?
No, sir. Sir, could you scroll up? Yes, sir, done.
Okay. So kinetic energy, you know, is equal to half mv square. Half m value will be in multiply, and this is v square. Actually, it was like this: half m, and your v square value was like this. So m was cancelled out. Okay, reason, see, your velocity value was QET by m. Q square, E square, T square by m square. Understood?
Yes, sir.
Hmm. Because of the positive charge, direction of electric field and acceleration will be same. Why it is like this? Direction of electric field will be same. But if charge is negative, then electric field will oppose. Then electric field will oppose accordingly. And that's why acceleration will be in the opposite direction. What is this ACC? Acceleration again. I will write this on in short form. ACC, acceleration. Acceleration oppose the electric field. That's why. Understood? Any doubt, guys?
No, sir.
So, next, if charge in the electric flux, if charge inside is zero, then electric flux is zero. Example, if you have Q charge and you want to know, I have to put here. Are you getting background noise, guys?
Yes,
Yes.
sir.
You are getting?
Yes, sir.
Hmm.
Hello, hello.
Not now.
Yes.
Yeah, not now. Now I'm using earphone now. So, if you take a box, cube-like structure, Remember, in all this situation, we are using cube. In case of cube, if you know total electric flux because of the total charge will be equal to Q by epsilon for complete cube. Correct. For complete cube, your total electric flux in a complete cube will be this. Barinder, how many sides do we have in a cube?
6.
Six. So one cube have six sides. How? Example, your room is like cube. You have four wall, one roof, and one floor. Total six. Four wall, one roof, and one floor. Got it?
Yes.
Sarah, how many corner do we have in a cube?
Eight.
Eight. So eight corner. Chandana, how many edge do we have in a cube? One, two, three, four,
Sir, 8.
five, six, seven, eight, nine, 10, 11, 12. How many edge do we have? 12 edges. Understood? Each line is one edge. This is
Yes.
one edge. Okay. So if you understand this really well, then things will become easy for you. How? You know through six side, one complete cube means for six side, I will use extended version of this. I will use extended version of this. How? Example, if you take for six side, your phi value will be equal to Q by epsilon naught. For one side, any doubt, guys?
No, sir.
Huh. Second, now this is placed at one face or side. Side or face, same thing. So, what will happen? Half of the charge will be present in this cube, and there will be one more adjacent cube that will face the electric flux. So, actually, in one cube there is q by two charge. You know, if in reality you have q by two charge, then things will become easy. Understood? But in reality, it is q only. Amount of charge responsible for electric flux in one cube is q by two. Correct? In each cube, charge distributed will be q by two. This is important. Ladbazi mummy. Understood, guys?
Yes, sir.
If you take corner, because you know if charge is present at corner, charge that is contributing in one cube will be q by 8. Same reason. If you know here you have one charge, Here you have one charge. How much it is contributing in one cube? Q by 8, because you have total 8 corner. Okay. And if you include face also, then what happen in case of face? Q by 8, and there are three face. One, upper one, 2, and side one, 3. Okay, two adjacent wall and one upper roof. Understood? It is also distributing in this. So if you consider face with corner, huh? So Q by 24. Any doubt? Because it is distributed in three face, and each face have only Q by 8. Any doubt, guys?
No, sir.
If charge is placed at edge, what is edge? Example, this. This is one edge. Now, this charge will be distributed among the four cubes, not one, two, three, total four cubes. So, if charge is placed at the edge, at the cube, so how much charge will be contributed in the one cube? Understood? Any doubt,
Sir,
guys?
can you explain once?
If you have one cube, this, this is one cube, okay? And if you place charge at this edge, Q charge. Example, if you place a ball at the edge of your room, then your room and your side room will share this ball, correct?
Yes.
And two room above also share the same edge, correct? Your room, side room, above and side above. Make sense?
Yes, sir.
Anybody have doubt? Anybody have doubt? Let me know.
No, sir.
Ah, So whenever you see this edge like here upper side, so it will be side and two room above will share the same thing. Okay. In case of cylinder, if you want to calculate electric flux, then you know electric flux will be because of the three parts. One, two, and three. Total electric flux will be because of these three parts. Charge by epsilon. Okay. Remaining thing, these are the questions solved. Yeah, this is also important. If you want to calculate electric field at the center of anything, have some angle alpha. It have some angle alpha. How to calculate? It will be 2k lambda by r. This is common, we did already. And because there will be some angle involved, it will be sine alpha by 2. Understood? Any angle. In this case, if you take this part 1, 2, so, and like this semicircle, what will be the angle alpha in this case? 180. That's why you take this. Am I audible, guys?
Yes, sir.
Huh. So next, here in this case, if you have two road, one with linear charge density plus lambda and minus lambda, distance between them is 2r. And if anything is present on the center, example positive charge. Let's take any positive test charge is present here. What will happen? Positive will repel this and negative will attract this. Can we say there will be double amount of electric field at the charge? Because E1 is the electric field repelled by the plus and E2 is the electric field by minus. Both are in the same direction. Can we say net electric field will be 2E? Yes or no? Net electric field will be 2E. And if this is net electric field, now you can calculate. You have to consider it like a road cylinder, 2 pi RL. This is lambda L by epsilon. You can calculate. Understood? Any doubt?
So can you explain the electric field at center once again?
The question given is like, I will draw this again. What I am able to recall, because I don't know the exact question, he, you have two road having same linear charge density but opposite sign, because this road have positive charge, this road have negative charge. Okay. Distance between two road is 2r. Distance between two road is 2r. If a charge particle, positive test charge, is placed at the center, if it is at center, can we say distance from the negative road will be r, distance from the positive road will be r. Got it? Now positive road will repel this because this is unit positive test charge with E1. Negative road will attract this with some electric field E2. Can we say both electric field are in same direction? They will add up.
Yes, sir.
And now we have to calculate how to calculate 1E.
Sir, I'll be back
Same
in
method.
5 minutes.
Okay, Anvita. So electric field is E. Area is 2 pi RL. Charge value is lambda L because you know linear charge density is equal to charge by length. So charge, instead of charge, you can write lambda into L. L will be cancelled. Your E value is 2 pi lambda by 2 pi R epsilon. But here electric field is double amount. Why double amount? Because both are in the same direction. So you can put double amount of this. Understood?
Yes, sir.
This question we already did. If force depend upon the unit vector. If you convert unit vector, you know it is uh, R vector by magnitude. Vector by magnitude. And because electron have negative charge, that's why. Okay. You had one question like this. If total length is 2L is equal to 10 centimeter. Basically, dipole have length 10 centimeter. It means L value will be 5 because half. Right? L value will be 5, half. And this will be equal to 500 microcoulomb. Okay. And your x value is r plus L square. Now r value is 20 centimeter. Sarah, can we take here r is much greater than L?
R greater than L.
R is much greater than L.
No, sir. I don't know.
We can't. We can't. If you have 5 kilometer in front of 5 centimeter, you can definitely ignore 5 centimeter, right? But they are very close to each other. Make sense?
Yes, sir.
So we cannot ignore, and we cannot put this formula for axial line. E is equal to 2 kp by r cube. We cannot apply this formula. Reason: this formula is valid only when r is much greater than L, like 1,000 times, 10,000 times. Okay. So if this is the situation, you have to apply real formula 2 kp r square minus L square the whole square. And just for comparison, I wrote this. If for equatorial line, formula is this. Okay. For equatorial line, this is the formula. Then apply the value, you will get answer. And out, guys, value doesn't matter. What really matters is how you will apply formula. Many people will try to put this formula and this will be wrong because we don't have this situation. Any doubt, guys?
No, sir.
Imagine this. You have work done, you have charge, you have displacement. You have to calculate electric field. E is not energy, it is electric field. How to calculate? Then you know work done is equal to force into displacement. By this, you can calculate force, work done by distance. And when you calculate force, then you know electric field is equal to force experienced by the charge. You have to calculate value. F you will calculate by this method. Charge you already have done. Tell me, guys, was it difficult?
No, sir.
Done. If you have two dipole, one dipole from minus q to plus q, like this. Second dipole here, minus q to plus q. So this will be your dipole moment. This will be another dipole moment. And dipole moment is a vector quantity. What will be the resultant dipole moment? This is the resultant. Can we say in this case your resultant P will be equal to P1 square plus P2 square under root? Done. This is what you are supposed to calculate. Because both value are exactly same. So 2p square under root. Done. Anybody have doubts?
No, sir.
we have this kind of question. Ki you have one sphere with this surface area density and this radius. Another radius with double, another sphere with double amount but same amount of surface area density. What will happen if you connect them? After contact, potential will be same. What will be the charge in the first situation? You know charge is equal to sigma into area. Area for sphere is this Q2 sigma into A2 because sigma value is same 4 pi r square. You can calculate this. This is the charge. Total charge this, add them, and you know even if you get new charge Q1 dash and Q2 dash after contact, it will be same 20 sigma pi r square. How to calculate in this case your what should I say? What are we supposed to do? Sigma value. Okay, new sigma value. For new sigma value, you need to calculate new charge. And what is the formula for new charge? Radius 1 and radius 2. Correct? 1 by 2. Correct? Total should be total should be this because this amount is fixed. Correct? This amount is fixed. Total should be this. So can we say if example if I take one value as 3.3, Q1 value let's take it is equal to total is 20, no 6.66 sigma pi r square. Then another value will be equal to what will be the value? 13.34, correct? Something like that. 32 sigma pi r square. Why I wrote like this? Because you have ratio 1 ratio 2. Now you calculated charge, you can calculate density. See, here I calculated this. If first charge is 20 by 3, then second charge will be 5 by 3. Value will be same. Sorry. Yeah. We did the same thing. We were right. Q1, another is double amount. This first value will be this. What will be second value? Same. What is this value? If you take 20 by 3, it will be 6.66. Same. What will be other value? What will be Q2 dash value? Double of this. What is the double amount of this? 40 by 3. Sigma pi r square. Okay. You can calculate sigma 1 and sigma 2 because charge by area. Understood, guys? Go check it once. Let me know if you understood this well or not. Otherwise, I'll explain this again. Understood? Yes or no?
Understood.
Huh. So what you are need to do? First, you calculate what is the total charge if you add both Q1 and Q2. Second, you take ratio of charge depend upon their radius ratio 1 by 2. Through this, you can calculate individual charge. Once, because we know total amount of charge before distribution and after distribution will be same. Then you can calculate new Q1, Q2, and through this it will be easy to calculate this. Because if you calculate new charge density, what will be new charge density? It will be new charge by area. Same if you want to calculate sigma 2, it will be Q2 dash by area of 2. You will get the answer. Understood? And I will show you again whenever we will solve question. Go through it and let me know your doubt. Chapter is done. Got it, guys?
Yes, sir.
Yes, sir.
Good. You have class at 4 o'clock. It will be chemical bond. Okay. I will cover almost 80% of the chemical bond this next class, except MOT, mostly MOT. Should I finish it here? Because I will take at class at 4. But better if I take some of your questions from every topic. These were the doubt questions. I will explain this last question. We did this topic. This was the question. That question. There is an electric field in X axis. If work done for this charge for this distance at this angle is this, what will be the electric field value? So because you know work done is equal to force into distance, force is equal to Q into E distance. Means this is FD cos theta, it will be equal to QE FD cos theta. So your E value will be equal to work done by charge, distance, and cos theta. So the value work done is 4, charge is zero point 0.2, distance is 2 meter, and cos 60 value. What is the cos 60 value? 1 by 2. What will be answer? 20. For these two questions, I will teach separately because these are important two questions. If other people come, it will be good. Electric flux. You know, here electric field is not passing through the surface. How do I know? Through the question. A surface of this in the plane of paper, in the plane of the paper, placed in the uniform electric field, acting along the same plane. So both are in the same plane. If both have same plane, it means electric lines are not passing through the surface. Electric lines are not passing through surface. Okay, this word is extremely important. This acting along the same plane. Same plane means they are not passing. Okay, if the plane of your mobile and plane of your pen are same, so pen will never pass through the mobile. Understood? Exactly
Yes.
same question here. Square surface of this in the plane of this. Uniform electric in the plane of the paper. Both are in the plane of paper. Both are in the plane of paper. So again, same answer. Ask your doubt. And you can see even through diagram, they are not entering, they are not perpendicular, but along the paper.
Understood, sir.
Yes. 17. Chandana. If R is 2 greater,
Sir,
2
R
point charge
cube.
this
1 divided by R
magnitude,
cube.
then because whether you take equatorial point or axial point, in both situations, electric field will be k cube by r cube in case of equatorial, 2k q by r cube in the axial. But in both situations, at least electric field is inversely proportional to r cube. Right? Polar molecule, polar molecule have permanent electric dipole moment. Pole means there is a positive and negative charge, so there will be dipole moment. This was the same question. You have three charges. You are like this. Your first charge plus q is placed at y-axis a, y-axis at a distance. Second minus q is placed at origin because all are zero. And next last plus q will be placed at this. This is also a. It's like two dipole are placed. It's like two dipole are placed. One here, another here. Okay. What will be the direction of the final magnetic field? This. Done. Okay. One electric field this, another electric field this, final will be this. This was that question. Key one distance is 20 centimeter, another distance 10 centimeter. You can't ignore one over other. So that's why your formula should be electric field along the axis will be 2kpx r square minus x square a whole square. This will be the formula. Okay. Next, all of you do one by one. This is for Sara. This is for Chandana. This is for Anvita. Let me tell you, torque is equal to R cross F or sorry E. No. P cross E. R cross. Why I messed it up? Torque is equal to R cross F. This torque is also equal to P cross E. Both are correct. Okay. Or torque is equal to PE sin theta. Or torque is equal to, P is equal to Q into 2L E sin theta. All four formula are correct.
So for 25, option B.
Yes. Sara and Anvita. Chandana, you can solve remaining two questions.
Yes.
Torque you have to calculate. Q 2 into 10 is to power minus 6. Distance 3 centimeter. E value 2 into 10 is to power 5.
Scroll down a little bit.
Yeah, C option. I'm getting.
Okay, and if angle is not given, you have to get 1. So 3 to the 6 to the 12. Minus 6 minus 8 plus 5. Yes. Sarah.
Sir, 2.
2. So you have to calculate what? Charge. You know charge will be equal to torque by charge is equal to L E sine theta. So what is torque value? 4 divided by what is the distance value? 2 into 10 raised to power minus 2. E value 2 into 10 raised to power 5. And sine 30 value 1 by 2. 2 2 cancel. 2 2 ja 4. Even I will not check other option. My number will be 2. Any doubts?
No, sir.
Sarah?
No, sir.
Sir, for 29, is it option A?
I think it should be semicircular arc, na? Semicircular arc angle will be 180 of radius this. Uniformly charged per unit length electric field at the center of the arc. So you know electric field is equal to 2k lambda by A into sine alpha by 2. It is 180, so sine 90. Correct? Sine 90 will be equal to 1, so it will be 2 into 4 pi epsilon naught lambda by A. Yes. Understood, guys? Direct formula. Electric field is equal to 2k lambda by A sine alpha by 2. This was the formula. This was the question. You have one radius R, another radius 2R, and both have surface charge density this. They come in contact and separate. What will be the new surface charge density? So if you calculate new charge Q1 by Q2, it will be R by 2R. It means 1 by 2. It means if you calculate Q2, it will be 2Q1. Correct? Yes. First, you have to calculate what will be Q1 value. Q1 value, Q value will be also equal to this is das. Q1 value will be equal to area. What will be area? 4 pi r square. Q2 sigma area. What is the area of the second? Here you have 2r. So 4 pi 2r square into 4r square. Okay. So this is 4 pi r square sigma. This is 16 pi r square sigma. What will be the total value? 16 plus 4, 20 pi r square sigma. This is the total charge. If Q2 value is Q1, double of Q1, can we say their addition Q1 plus Q2 will be equal to 20 pi r square sigma. Q2 value is 2Q1, so it will be 3Q1 this, and 3 will go to this side. 20 by 3 pi r square sigma. Correct? Same way Q2, you can calculate and you will get the answer. Any doubt, guys?
No,
So first calculate your normal Q1, Q2. You will get total answer this. Addition of both. Second, if new distribution of charge, total charge will remain same and potential will be same. Total charge remains same, potential will be same. You have to follow these two rules. Okay. This Sarah. In Gauss law of electrostatic, electric flux through a closed surface depend upon correct, how much charge is present inside. Correct, Sarah?
Yes, sir.
31. Who will tell? Chandana. A Q charge is placed at the center of the Q. What is the flux coming out through any of its face? Face means side. Same. I wrote already face. How many face we have, Chandana?
3 phases.
6 face total in a cube. 4
Yes,
wall,
sir.
roof and floor. So what will be the value through each face? Q by 6 absolute. Why minus 6? Because micro coulomb. Understood?
Yes, sir. Understood.
Anvita, 32. It is 0. So if all the charge is present inside, it cannot be 0. Electric field inside the surface necessity to be uniform. No. Magnitude of electric field on the surface is constant. No. Electric flux line enter and exit are same. So net 0. Make sense? Anvita, any doubt?
No, sir.
Next question. This. Sarah, a spherical conductor, this radius, this charge, uniformly distributed. Electric field at 15 centimeter. Yes or no, Sarah? You have to consider only outside distance, not inner distance does not matter. It is given in centimeter. You can calculate further. 3, 3 is a 9, 3 5 is a 3 5 is a correct. Minus 7 plus 9, so remaining 2. Minus 4 will go up, it will become plus 6. If you remove this 32 into 10 raised to power plus 5 divided by 25, what will be the answer? Any doubt, Sarah? Direct formula KQ by R square.
Yes, sir. No doubt.
This was the question, guys. You already understood this question. Ki there are two parallel infinite line charge. Two infinite line charge. One have plus lambda, another have minus lambda. And distance between them is 2r. Electric field in the midway of the charge. Total electric field at the center. Midway means center. So this distance will be r. This distance will be r. Because of the first one, it will be like this. Because of positive. Because of the negative, same. Total double. Any doubt, guys? ask me, is this chapter really difficult? Is this chapter really difficult?
No, sir.
This chapter is done, and we have to solve more number of questions. 3-7. You can take 20-minute full break. Don't do anything. Next half an hour, you have to send me how many questions you can do it. Let's take 2 minutes for each question, 3 minutes for each question, 10 questions. Send me 10 questions.
So till
Okay.
3:30.
No, class will be at 4.
Okay.
3:30 you take full break without any study. And at 4 o'clock, like from 3:30 to 4, you do 10 questions.
Okay.
Okay. How you guys feel, Anvita? Is it easy chapter?
Yes, sir, but I have to solve questions and I didn't write notes also. So
Okay.